My name is Michelle from Home Supplies, and I just want to tell you a little bit about the MILLIOHMY, which is a little gadget we've built to help you read milliohms. It's available on the website in various forms. You can either buy it as a full little gadgety meter like this, and all it does is plug directly into your existing multimeter, and you can read milliohms. You switch it on, you put it on a very low voltage range, and off you go. Dead simple. Really accurate too. I'm quite amazed with it. Also, it's available as a build kit, so if you want to make it yourself, it's a little bit cheaper. All the parts come with it. There's instructions and a circuit diagram, so you'll always be able to fix it. If it goes faulty, it's dead simple to fix. It can't, not that difficult for an engineer to do. Or alternatively, if you've got all the bits, it's available as a download, and then you can just download the instructions and everything's there. You can just make it yourself. The reason why we made it was because I watched a video from Mike Dranfield, and it was brilliant. Loved it. It'll be in the description somewhere when this is all put together. And he described how you fault find on an LCD screen with short circuit capacitors. So if you've got a bank of 10 capacitors going along and you need to find the faulty one, what the milliohm meter does is the closer you get to that faulty capacitor, the lower the reading will be. And then if you start going away the other side from the faulty capacitor, the higher the reading will go. So it's a bit like the Doppler effect of milliohms. That's the way I look at it. So it's brilliant to fault find on screens. And it's also really good to fault find on PCBs with short circuits, multi-layer boards, like this little devil here. This is the 32-inch one. I think it's a T range, and that goes dead short. And I know we all know it goes dead short now, but if I'd known that originally, I wouldn't have spent hours piddling about trying to fault find on it. Originally, on one of the boards, I found a short circuit down here on one of the regulators. Don't know that you can see it, doesn't really matter. But then when, after I'd built the milliohmy, I thought, oh, I wonder, as I knew it was faulty anyway. So I started moving my meter readings closer and closer. And the closer I got to the microprocessor, the lower the reading went from the milliohm meter, which I thought was brilliant. And then today I've been using it to fault find on some power supplies that I get the units from to repair for some subwoofers. So these are the power supplies for them, and some of them, these ones have all got no 54 volts, and I thought I knew all the 54 volt things, but there are a couple of faults I still haven't found, and I was wondering whether I had faulty transformers. So I've been using the milliohm meter to try and fault find on these boards this afternoon, and I found it really accurate. My meter, I use an Avo. Love it to bits, had it forever. It's fantastic. And I do most of my fault finding on the diode range. And this, the milliohm meter, because it's really a low voltage that's produced, that shows you like millivolts, or well, it can produce up to, because it's got a 9-volt battery, it's about 8.5 volts. So you can use it to fault find over the whole circuit and not just across short circuits. So diodes read like diodes, so you'd have a 0.7 or a 0.9 or whatever, and a transistor. But then resistors read the accurate reading. So a 2 ohm resistor might read 2 millivolts or something. So you've just got to transfer it, times it by 10 to get the accurate reading. So it seems that today, when I was using this with this meter plugged in, I could then fault find across a whole board without having to switch between ranges or worry about anything else. And so I liked it before, and today I absolutely love it. So that's the introduction to the milliohm meter. So like I said, the links and stuff will be in the description if you want to buy one. And I'll put the link to Mike Dranfield in the description, and then I'm going to show you, I'm going to try and link it through because I've never done one of these before. I'm going to try and show you some fault finding with a USB camera and see whether it can do that. Okay, right, off we go.
Okay, on this TV we've got backlight, but we've got no picture content. Now, by disconnecting one of the ribbons, we can prove that there's a short on the screen using a normal meter. So, for instance, if I use this capacitor, we have a reading very similar to a diode. On this capacitor, we have a short. Now, these capacitors are on the same rail, so each of the capacitors that's attached to the rail will show a short. However, we don't know which capacitor is faulty because they're all on the same rail. If we use the MILLIOHMY and switch it on, if we read across the same capacitors that we've marked in red, so we can see which ones are which, what we're looking for is the lowest reading. So on this one, we've got a reading of 41. On this one, we have a reading of 31. On this one, we have a reading of 20. This one, we have a reading of 30. So they're actually going, the readings now are getting higher.
The Doppler effect.
And on this one, 43. So logic tells us that the faulty capacitor is the one with the lowest, which reads 20, is C2405.
How quick was that to diagnose?
Very. Now, I've removed the diode that we suspect was causing the short, and if I use the meter,
Both ways.
now shows that the short has gone. If you use the MILLIOHMY, depending upon which way I have it, it will either read like a diode or it will show nearly 8 volts, which is what the MILLIOHMY outputs at. It shows that the short's gone. Okay, so I've replaced the cap with another one. I'll plug it in, and if it's worked, we should hopefully see a picture. If it hasn't, then we won't. So, plug it in. And we have a Philips logo.
So how much time have you saved, would you say,
Well,
on the diagnosis?
Probably about 15 minutes, because the only other way to do it would be to remove each of the caps or lift each of the caps until the short had disappeared. And the chances are that when you lift the cap, bear in mind the board tends to be on a slant, it goes down that little crack there and you spend another 10 minutes trying to get it out. If you leave the capacitors down there, when you stand the screen upright, there's a very good chance you'll crack the screen anywhere at the bottom. So it saved me a lot of time.
Hooray for the
MILLIOHMY.
So that was a quick introduction to the MILLIOHMY. I've changed the box design slightly so it's a little bit smaller, not as bulky. The hinge works a bit better. This just is Andy's one, so he gets to keep this as the prototype. We've just shown that it reduces the time to diagnose on the screens, and it reduces it quite a lot because Andy could be sitting there half an hour taking caps off, the caps falling off, losing them in the sets, and now within 5 minutes he knows exactly which one's faulty. and the repairs done, dusted, whole lot back together within half an hour. We also use it now to diagnose multi-layer PCBs and power supplies. So it turns out that that transformer on the Cambridge amp that I was working on yesterday is faulty, so I need to get another transformer, pop that in, and hopefully I'll get my 54 volts back up on that. So all everything should be in all the links in the description. And thanks for watching. Take care. Bye bye.